get this going. All right, this is yours.
Thank you, Tammy. Really appreciate the opportunity to speak to the team here. So, hi everyone, and welcome to this presentation on configuration management of variants across the digital thread. My name is Henrik Mattfolk. I'm a principal systems engineer at Whirlpool, and I'm also the technical lead for implementing systems engineering processes, kind of deployment of systems engineering processes in the organization and educating the organization on systems engineering. We also deal with the tool set that is kind of supporting those processes. The topic of today is actually kind of a continuation of the presentation that I gave at this event last year. That was called the Digital Thread Enabler of Automated Requirement Quality Assessment. And maybe to some extent, the order of these two presentations may be backwards. Last year's presentation was on some of the value that you can extract or get from establishing and having artifacts integrated in the digital thread. So that is kind of when you do all the hard work, what you can harvest. But there are additional mechanisms needed, especially in the tools, for that to work, or at least to kind of work easily. And that is what we're going to talk about today. So the purpose with this presentation is I want to shed some light on configuration management, especially in context of a well-established digital thread and how those two things can really be complementary to each other. I'm not going to talk about any specific tool set here or endorse any tools, but we're going to talk about concepts and ideas that are kind of powerful and can make your life a little bit easier. I will talk a little bit though about OSLC and some of the kind of concepts used in OSLC, which is an open standard and that can be used by any vendor. I also want this presentation to work as a push to tool vendors, not just the ones we work with on a daily basis, but those that are active in this domain to basically think about how to modernize configuration management, especially in a quite kind of complex context of product lines. What I'm going to talk about today is kind of based on the experience that we have gained working with this over many, many years. I'm not going to claim that this is the only approach or even state of the art, but it has proven to work pretty well for us. So yeah, just to give you a little bit of context there. So the question is, when integrating artifacts across the lifecycle in the digital thread, do we need configuration records? And that is what we're going to elaborate on in this presentation, and basically bring out a couple of use cases or jobs where that can really help. I'm also giving this kind of talk in kind of our context. So I think it's important for you to know a little bit what our context is. We're a product line company. We deal with a lot of different product types. We have many architectures and a lot of technical models and a vast number of individual SKUs. And that is making kind of configuration management of systems to a challenge when we take it to this scale, especially when we start to create a lot of trace links and connect our artifacts. So the agenda for today, I will start with a little bit configuration management 101, just to kind of introduce some terms and explain a little bit the basic stuff here. Probably many of you know these things already, but and then I'll talk a little bit about the system meta model and a little bit aspects on that when it comes to MBSE and PLM domains and how that can impose a little bit of a challenge for us. Talk a little bit about trace links as well. That can maybe be seen as, yeah, that's just a link, but that comes with some different level of capability as well. And then we have the main section on basically surfacing a couple of needs and some of the jobs that different stakeholders are trying to do, where the digital thread and configuration management across can really help. So I'll elaborate on a couple of use cases there. And then we'll spend a little bit of time on feature-based approach to generating configurations, which is kind of a little bit like the new cool kid on the block, but also very challenging. And then we will wrap it up. All right, so let's get into some basic stuff here. So first of all, what is the purpose with configuration management? So just taken directly from 15288, the purpose of the configuration management process is to manage and control system elements and configurations over the life cycle. So a little bit the way we see it, if you see configuration management as a function or a capability that the organization actually performs, the input here is really configuration items, or maybe I should say candidate configuration items, and they can be either like the current version, or they can be baselines. And when we're done with this kind of management thing, we produce either configuration records in the shape of baselines, but we also see configuration records as they can also be like the in-work version, like the live version. And I'm gonna, throughout this presentation, I want you to think about configuration records as not necessarily just baselines. That can be kind of my current in-work version as well, that they can contain configuration items that are like the current version. So what are these candidate configuration items? Yeah, maybe traditionally it's really common to focus on kind of the design domain and your bill of material and the design definitions there. But really, we're looking across the entire life cycle of the system, and having configuration items starting already up in the business opportunity, stakeholder needs, expectation, the life cycle concepts, going down through requirements, architecture definitions, and the verification activities, validation activities on the right side of the V, and of course including the design definition there at the bottom. So that is kind of a little bit what's expanding here, and a little bit what the push here as well, that we want configurations to be able to have a broad scope when it comes to configuration items. And if we look at that a little bit more kind of in the real world, or a little bit over time, looking at different system stages, when are we actually producing these configuration items? Yeah, of course, a lot is in the conceptual phase and development phase, but not only. See a need for maintaining system configurations also throughout the entire life cycle of the system, and basically update it as we go. And one thing I like to point out here is, if we see kind of configurations as a little bit like stemming out from the physical architecture, we're a little bit in trouble, because that may not be available until maybe the development phase. But we like to start these configurations already in the conceptual phase, where maybe we have just the upper left part of the V and maybe some architecture going. So it's important to be able to start these configurations early in the life cycle. So let me define these terms a little bit better. I'm not going to claim that this is an industry way of looking at it, but it's the way we are looking at it. So I want to talk about configuration records, configuration items, and the digital thread. And you see here at the top here, you have different kinds of artifacts. This is not an exhaustive list of artifacts, but it's kind of sufficient to make the point here. And below here, you have some boxes. So for example, here requirements. So these individual boxes here, they represents the individual requirements. And then you see kind of a wrapper around those artifacts there. And that is what we think of as the configuration item. That can come in, can be baselines, can be like an in-work version. And the same for other artifacts here, like lifecycle concept needs and so on. And of course, these configuration items, they will come in many different versions. Maybe you create versions of requirement sets that goes into different configurations. Maybe if you talk about lifecycle concepts, we have many of those that we include in a configuration and choose to support. Again, these can also be like baselines, or they can be in-work versions. So the configuration record that contains configuration, or not contains, but it references at least configuration items. So we're saying here, okay, this is a configuration record for this product. I'm including that version of that configuration item and that version of that one, and so on. So you start to kind of build your product configuration that way. And that represents the configuration record. Again, can be a baseline, or we can work with some kind of in-work version of it. And then we have the connections between the artifacts, and we trace needs to our lifecycle concepts, to requirements trace to design, and so on, and the verification results. That is what we refer to as, sure, these are kind of trace link and the traceability, but this is a little bit more what we think of when we say the digital thread, and creating like a digital thread between these artifacts as they transform throughout the life cycle of the system. So just so you understand a little bit how I'm using those terms. And so to summarize that, so a configuration item contains artifacts that describes the system. A product configuration record contains configuration items that applies to the system, and the digital thread, that's kind of the connection between the artifacts. I like to mention this paper that I think was mentioned actually yesterday, the integrated data set, and that talks about exactly what I showed in the last slide. Use the term kind of integrated data set for kind of the all these artifacts kind of brought together, serving as a foundation for systems engineering. That creates kind of, I also choose to see that a little bit as that creates kind of the underlying model of the system, if you want to talk about model-based systems engineering. But I think this is kind of a model on its own right, that connects all these artifacts. And to organize these things, we need an ontology for housekeeping. What kind of artifacts do we have, or which kind, and what are their relationships between or with other artifacts. So that piece is important. And So this is kind of an example of a meta model that we use. Pretty straightforward. It's not kind of complete, but just kind of to make a point here. I'm saying this is kind of MBSE centric, so maybe apply an abstraction that makes sense for systems engineers. But if you take this view on this meta model and you talk to a design team about that, they may get a little bit offended that their whole complex domain of design definitions has been kind of reduced to one single box there. It's not that simple, right? No, it's not. So if we zoom in a little bit on the design definition, that's often a lot of different things that comes together to describe the design. You may have behavioral functional specs, you have a CAD model that describes the kind of physical form. There might be compiled software, source code, some styling stuff and color things, even simulation models. So yeah, this is a whole kind of new world that opens up here. And we get a little bit of challenge here. So if we put these two things kind of side by side here, you have some artifacts there that maybe belong to the more traditional MBSE domain, and then we have more the PLM domain or design domain. What we want to do, we want to create a digital thread that spans across these domains. We want to create configurations that spans across these, that contains items from the complete life cycle. And I mean, there are exceptions, but often you have tool vendor A kind of operating in the little bit kind of MBSE domain there, and you have tool vendor B operating in the other domain. And they don't necessarily talk very well to each other. And that creates a problem for us as kind of end users when we would like to create these things, but we run into kind of interoperability things between tools. And that's again where OSSC is one of the solutions to create that kind of good integration. So I think that's really important moving forward. If we should be able to do this better, this integration need to improve in general, and it would be fantastic to have one standard there. Let me talk a little bit about the trace links. And before I do that, I want to explain two different terms I'm going to use here. I'm going to use the term variant and revision. So a variant of something is, for example, I have 3 different variants of my system, and they live in parallel. They are slightly different. They will all exist kind of in parallel. While a revision is maybe I'm revising that variant throughout its life, and those are kind of historical baselines or current versions, if you want, that was in the past. I'm also going to show a lot of trace links, and I'm going to use this way of depicting. Often, many tools use the concept of when we create a trace link, it's not stored on both sides of the relationship, it's stored on one side of the relationship. And that's conceptually how you want to think about the links. And I'm depicting that in the slides with this round circle here, so you know what that means. That's the storage location of the link. All right. So let's look at a couple of different approaches we can take to linking here. Maybe the simplest one is just a simple one-way link, more known as a regular web link. For example, we can establish a link on the design definition that points to the requirement. And when we do that, when we explore the design definition, we see that link over to the requirement. But if you look at this relationship from the requirement side, the requirement has 0 clue that someone actually linked to it. You can try to fix that by creating another link stored on the requirement pointing to the design definition. And now you probably even made it worse, because now you have two links that risk to be kind of out of sync or get out of sync if you change it on one side of the relationship. Yeah, but that works. So a one-way link is one way of linking, but be careful. Yeah, the other one is called a reverse lookup, and that is also what is used in OSSC. So kind of the same thing. It's one link there stored on the one side of the relationship, in this case on the design definition, usually the downstream artifact. And when you look at this from the requirement side, you still see that link. And the reason is because maybe it's the tool, but the tool does a reverse lookup to check, hey, anyone linking to this? And yeah, this one does. So then we will show that link there. So that sounds like that's the perfect solution, but it can come with some challenges too. So for example, imagine now that we revise this design definition, and okay, the link comes with that kind of revision as well. So now we have two different revisions pointing to that requirement. What do we expect now when we look at this relationship from the requirement side? Do we expect to see two links or one? Yeah, that's where a context start to matter. Yeah, and if we can, when we explore these artifacts, if we know in which context, we can say that, yeah, it's Rev 1 that's part of this context, not Rev 2. So don't show the link to Rev 2 when we look at it from that direction. So here a context start to matter when we do reverse lookup, and also just to avoid to query the entire universe for reverse lookup links. The other approach I would like to talk about is variants, pointing or linking to variants versus revisions. So here, for example, we have a requirement A of variant 3. We can establish a link to that, okay? But now we create another variant that live in parallel, maybe included in a different system version actually, or variant. Yeah, we need to create a link to that one too. So now we have two links on that verification method that is the same. And then maybe requirement A variant 1 comes in many revisions. You can actually create a link to a specific revision on that variant. And you see how that can start to get a little bit messy with the management of these things, especially if we go to the revision level. So if the revision change, I have to go and change the link to point to a new revision. And then there is this other concept in OSSC, which I'm not sure about the right name, but I call it the dynamic link here. And the way that works is, yeah, you have the same verification method there, but we are creating a link that will maybe point to requirement A, but we haven't really decided which variant of requirement A or even revision of variant A. We're just saying that, yeah, this is a link to requirement A, but we're letting a context configure the link dynamically. So, oh, you're exploring this verification method in this configuration context. Okay, then the link is pointing to, let's say, variant 2. So that is dynamically managed. The benefit with this approach is that you don't need to create a lot of links. You create them once basically, and then you can create as many contexts as you want or configurations, and just make sure you configure which variant that applies to that particular configuration, and then the link will be fine. That is a kind of little bit the gold standard in my opinion. Comes with some challenges as well, but it makes management of links really simple. All right, so last thing here. There's a concept, link validity, that you probably worked with, and that can help you, especially when you work with version specific links, but not revision specific links. So imagine this relationship here, for example. We have a design definition Rev1 and the requirement Rev1. Okay, is that relationship valid? Can look at those two revisions and say, yeah, they're fine, and we confirm it. All right. Then we create another revision. We revise the requirement. Okay, since my link is also equally pointing to that one, so I don't need to do anything with a link. But it begs the question: okay, is that relationship still valid, or do I also need to change the design definition to be valid with that revision? So then you can go in and no. Well, initially maybe you don't know, but then yeah, that's fine too. That's okay. And okay, so this can seem pretty straightforward, right? And easy for like these two artifacts, no problem. But when you take this to scale and you have a lot of different artifacts to deal with and a vast amount of links, it can get kind of tedious and a little bit messy to kind of do all this kind of validate, kind of confirm all the links valid. And there's another thing here, and usually tools lack the capability of only flagging when relevant things change on the requirement. I can revise the requirement and maybe change an attribute that has something to do with some administrative thing, doesn't change the meaning of the requirement. I still have to go in and check it as valid. We see some tools that are smarter now, and they start to implement capabilities where they can actually look at a subset of the attributes to check off validity. So that's an improvement for sure. That's a good direction in my opinion. So now let's get into kind of the main section here with looking at some of the needs and jobs that stakeholders are doing, or some of our engineers, and especially the ones where the digital thread and configuration management play a role and can help. So we're going to look at we're going to look at two main jobs. I'm going to talk a little bit about the third. So we're going to look at defining a new system configuration, and then we're going to dive a little bit deeper into the third one, analyze correctness and completeness of the system definition. So those are the two main jobs we're going to look at here. So the first one, define a new system configuration, that contains a couple of like sub use cases. And when we do that, we often need to, we probably need to create some new configuration items, and we need to update configuration items, and we're also reusing configuration items. And whenever we change something related to the configuration items, we get into this use case of establish or maintain traceability that can get pretty tricky, especially when we change a lot of stuff. So, and engineers here are kind of careful with their time. They don't have a ton of time available. So if we look at some of the stakeholder needs or expectations here, they definitely like to minimize the time it takes to define these system configurations, especially if you think about the context where we managed a vast number of system configurations that need to be fairly quick. And this traceability thing here, same thing there. We definitely want to minimize the time someone needs to spend on just managing traceability. But maybe even more important, we want to maximize the correctness of the trace links. We don't want trace links to be kind of a little bit neglected, and so it kind of erodes the trust in the trace links. Probably no one looked at that, so yeah, I won't be able to trust it. We want really that to those links to be correct so people can use them for something useful. So I'm going to get into basically this use case here that kind of invokes these three here. So we're going to create a new configuration plus configuration items. So if we look at a system here, system A, we may have needs, system requirements, we have a design definition, and of course they live in different tools. We have some component requirements and some design definitions for those components. So, okay, now we're going to create system B, but it's very similar to system A, so we would kind of like to use this as a template. So what do we start to do? We start probably with kind of saving the needs to, okay, or create a new version of the needs so that can apply to system B, and I'm going to do the same thing for the requirements. Going to save that as a system B variant. When I do that, depending on the storage location of the links, they're going to come with. And when I do that for the system requirements, okay, the trace link is going to come with, but they're going to point to the needs for system A. And they're going to point to also the component requirements, of course. And this is not what I want. And so I'm going to have to adjust that, remove that link, and I'm going to have to readjust it to point to that version of the needs instead. And I need a new design definition as well. Or actually, maybe there was one link here. Maybe this is kind of a defeatured version of the systems. I'm not including all the component stuff here, so I'm removing a link there. And then I'm creating a new version of the design definition, so I'm saving that as well. So what happens then? Yeah, of course, those links are pointing to system A's requirement, but that's not what I want. So now I'm going to have to adjust the links again, remove that, and make them point to the version I intend. So this kind of manual adjusting of links is time consuming, and it's also prone to errors because you may forget to adjust some of these links. And we really want this to be automated and not manual. So let's look at how can a configuration record help us in this. So imagine that we have a configuration record that defines system A here. Here's the needs, the requirements, and the rest of the stuff that applies to system A. And so what I want to do now is to create a configuration for system B. Maybe I don't want to create new versions for everything related to system A, but I want to do that for a couple of things. So let's say I have a way to highlight that. Okay, those things I would like a new version for, but the rest I'm going to reuse. So I'm going to leave them as they are. And now we can do this as a one-click operation. And the tool could allow me to create a new version of these things without me having to do it individually for each. And it can also at the same time adjust the trace links to, okay, so those links should be the same there, of course, in the new version. So I don't need to kind of deal with that manually after I kind of created manually new versions for those. And of course, initiating a new configuration record for system B, then you can include, or that can be automatic, of course, to include those in the system B configuration record. So that is a kind of more automated way of looking at it, and it would be fantastic to be able to do that. So now let's look at it, the other use case here related to reusing configuration items. So basically the ones in the previous example, but the ones that I did not like to copy. And here is three artifacts we have for system A. basically this is the configuration for system A. Here's the requirement set, here's the architecture definition, and here's the design definition. All right, now we're going to create system B, but system B is going to be off of the same architecture. So what do? Okay, I create system B requirement set and system B design definition, and I establish the trace links. We're using the same architecture here, so we're linking to the same architecture definition. So the question here now is, what belongs to system B? If we just stare at the links, that's going to be a little bit confusing. I can see that system B is using that architecture, jump to the architecture. Now it's pointing to two different requirement sets, which ones apply and so on. So we get these kind of reused items to be a little bit of a kind of confounder for the configurations. And while this is a digital thread for sure, it starts to feel a little bit more like a digital threat at this point. It's getting a little bit kind of confounded. So here's another situation where a configuration record could help us. So we don't need to, so we can get basically an unambiguous definition of what applies to system B. So we can point to those configuration items and clearly define what's included there. The other approach would be to, I can of course create a new variant of the architecture definition. I can keep the trace links confined to that version of the architecture definition, and now I have a pretty good definition too of my system B. But I branched the architecture definition for no reason, actually. I'm not changing the architecture definition, but it looks like I am because I'm creating another version. So that kind of duplicates that definition, and that is not so good. It creates additional complexity in the on the artifacts, and also it's a little bit confusing how many architectures do we actually have. It will also be challenging to do a where used. If you keep it to one architecture definition, you can do a where used and see that, oh, that's used in those two different configurations. But here you kind of lose that opportunity. So the last use case I'd like to walk you through here on the new configuration thing is when we update configuration items and a little bit traceability with other artifacts. So we're not creating new versions, we're just revising them. Okay. So in this case, a design definition of a certain revision, a requirement set of a certain revision, and creating Rev2 of that requirement set. And if this link is a version or a revision, a version kind of link, then you won't need to create a new link. But if you're linking to revisions, you have to create a new link to that revision. And then maybe you create Rev3 of the requirement set. And yeah, that was a stretch for the design definition. I need to revise that. Oops, initially it points to those two revisions as well. That was not what I wanted. I have to adjust those links, make it point to revision 3 instead. And now this is kind of manageable for a few relationships. But if you imagine you take this to scale and we have hundreds or maybe thousands of links per configuration, and you multiply that with many configurations, it starts to get kind of complex and a lot of management related to this. So let's look at how could a configuration record help us to minimize this management? So here we looked at 2 artifacts, but if we look at this at scale, we have architecture definitions, requirements, design definitions, and a lot of artifacts. The trace links between these things probably look something more like this. I know it looks really messy. You're not looking at this all at once like this, but this is probably more likely what it's going to look like. And in the example, we were kind of changing some requirements. We created a new revision of the requirements there. We revised the design definition accordingly. So we kind of worked with that and said, okay, that revision of the design works with that revision of the requirements. But if we kind of manage the validity between these revisions on the link level, you need to go and make sure that you check off those validity relationships, or maybe adjust links accordingly. Hopefully you don't forget any. But could a configuration record help us here? Actually, it can. So let's say that we have a configuration record for the system already, including some specific revisions of the requirements, architecture definition, and design definition. And we know what we did, right? We revised the requirements and we revised the design definition. Okay, so we kind of checked off that already. Now let me just confirm the validity between Rev E and Rev O, and that could actually be used, could actually be done in the configuration record. So I revised the configuration record. I include new revisions there on the requirements and design definition, and now we're good to go. Please automatically adjust my links and confirm validity, or you're basically confirming validity with the configuration record. So that is just a way that can save you a lot of time if you can do it that way, instead of managing that at each individual link level. Of course, the configuration records need to be diligently managed, becomes important. So, but maybe better to focus your effort there than on each individual link. Yeah. So the last use case I'd like to show you here is this one here, to analyze correctness and completeness of the system definition, and could be at least 2 different roles here: the systems engineer and maybe some kind of quality manager like to do this. And maybe the quality manager has a little bit broader scope here, like to know that our artifacts are well connected. Do we have the right kind of maturity of these artifacts given different gates in the project? Do we have all the requirements verified before we release the product and so on? While the systems engineer is also, of course, interested in completeness, and you want to reduce the risk of basically having an incomplete or incorrect system definition that imposes a risk for the project, of course. And again, we want to kind of minimize the time it takes to do this, and of course just enable us to do that in the first place, and especially to do that with very little effort. And that was basically what I talked about last year when we were looking at how you can analyze requirement quality by using the relationships between the artifacts, and actually you had configurations in the background then to define what was actually included in a certain configuration. So one challenge here, if you do not have a configuration record that clearly defines all the artifacts included in your configuration, and you rely on trace links, then you get into a little bit of a problem, because you can have like, all right, here's a function, but it's an orphan function. It doesn't link to anything. Will you be able to find that function if you rely only on trace links? Probably you won't trace to it if there's no link to it. Or, for example, a stakeholder need that doesn't trace to anything. How will you find that need if the links or if any link has not been established yet? So this is where configuration and configuration items can really help you, because what that will define is the artifacts that are applicable to the configuration independent on established traceability. So it's like you do kind of a little bit of a pre-step. You're saying, okay, here's I'm wrapping my set of artifacts into these configuration items, and I'm kind of connecting that to my configuration. Okay, I'm going to get to the trace links, but that may not be the first thing you get to. So it's also a quick way to start to build your configurations, even though the individual links may not yet have been established. And also, if you like to automate this analysis and basically run through all the artifacts, show me all the stakeholder needs, are they properly linked? Maybe I'm looking to confirm completeness. Then this configuration record becomes pretty powerful in order to find all those needs and look at if they have traceability to stuff they should be connected to. So it's definitely a good way to find kind of orphan artifacts that may or may not be a problem, but then you can at least look into it. There was this other use case about finding information about a configuration. That can also be a little bit tedious if you're kind of jumping several kind of trace links to find the stuff that you're looking for. And that's also where a configuration record could really help you, because that serves as kind of the list, like your bill of information for that system. And you open that and say, oh, I'm looking for that. Okay, boom, open that pretty quick. So we do see that as a quick way to find what you are looking for, maybe a little bit independent from the individual trace links, which are super important for other kind of things as well, and for this kind of analysis, for example, that relies on the trace link. Impact analysis in general relies on those individual trace links. It's not enough to just know which artifacts that applies to configuration. So I think in the previous presentation, I like that illustration where those kind of connections between the artifacts, that was kind of changing from like just having information to knowledge and wisdom. Yeah, that is kind of what's creating your wisdom at the end of the day. All right. I'll go a little bit quick here. Little bit kind of the future here is we're looking into feature-based configuration management, and I think that can save us a lot of time, especially if we apply it on specific areas. So this is from the ISO standard 26580. So if you're kind of into this, I can really recommend you to go through that ISO standard. There's a couple of core concepts here when it comes to being able to do this. It starts from some kind of superset, or we call it an overbuilt set, or 150% model of your artifacts across the V. And that also need to be developed feature centric. So when you create that kind of 150% version of things, you need to have a feature centric view into those. So you can use that when you want to generate your assets that applies to a specific system. And that is done through a feature catalog that defines the features that kind of exist, and how you can also, can you combine that feature with that feature, and so on. Yeah. And then you, in order to create a specific configuration of a system, you basically make choices. You create a bill of features, and then you feed some kind of PLE factory here with that bill of feature, and then it knows how to kind of scale down and change these artifacts to properly describe that particular system that has those kind of features. So that sounds pretty simple and straightforward, but it is for sure an upfront investment. And we also, I mean, there are some tools out there today that can do this, but I think there is a little bit more to wish in terms of capabilities from those tools. This is basically saying the same thing. So, and I introduced the 150% kind of term here, same thing as the superset. And yeah, same thing here. We can generate artifacts here at different levels. And the thing is, you don't necessarily need to go with an approach to automatically generate everything based on some overbuilt stuff. So you can be a little bit choosy here. And one way of kind of approaching this that we have looked into, but we're not so far down this road yet, is to look at where do we have artifacts with a lot of variants. For example, the system requirement set, the physical architecture, the BOM, and I mean the product configuration itself, of course. It would be very nice to be able to generate those and not have to manually build those configurations. So what I showed you in the previous slides was everything was actually manual. Even if the tool helps you to create the variants, the actual content you have to still manually create or adjust. Here, it's kind of generated based on feature selections. So yeah, I'm gonna skip that one, and let's jump to the summary here. So a little bit to just kind of wrap this up. So configuration records, how can they benefit you? So if we have a separate configuration record, we can start to create configurations really in an early stage of the life cycle, even before we start to get a design definition. And it will definitely help us on automating analysis and different reports, especially if you want to create them in context of system configuration. That becomes a good way to know exactly what is part of that configuration. Even a computer can understand it. So it's that good. It can, as we saw in that kind of use case, it can help you to automate creation of new configurations. That can be pretty tedious if you have to do that really manual and adjust trace links and all that. But it can really help you to create some structure and define context for trace links. Definitely reduce the cost of maintaining those trace links. And I believe also that we can avoid to duplicate things just because of traceability reasons. So it basically reduces the artifact complexity. Even if you may create trace links incorrectly, having a configuration record that clearly defines what's part of this or what applies to the system kind of compensate a little bit for that. Yeah, okay, you created that link incorrectly, but I know that that artifact is still part of this configuration. So it can help there. And again, it's also a quick way to find information that is applicable to a specific configuration without having to do like a trace analysis and spend time on that. So a little bit kind of the call to action here for tool vendors. We do see sometimes that, especially if we compare PLM and MBSE kind of oriented tools, that they may have a slightly different approach to configuration management, that even if interoperability is there, even just that can impose a little bit of a problem. So it would be nice to have kind of a unified approach there. Definitely allow us to create configuration records that spans the entire life cycle, and from these different domains, so we can increase the scope of those configuration records and the digital thread. We see very little support for feature-based generation of configurations, especially in the native tools. There's some exceptions, but there are also like add-on tools that you can add to your toolset to do this, but why not be able to do that in the native tools? We face some issues and kind of high cost of creating our tool ecosystem, just because there's poor interoperability between many tools. So OSSC is trying to fix that. That is the solution. I know that you can probably use other ways to fix it, but that's really what we ideally would like to be able to do. Hey, that's an awesome architecture design tool, and here's a good PLM tool. Let's use those. But do they talk to each other? Yeah, and I think with that, I'm gonna open up for any questions.
We do have one in the chat from Craig. Can you see that?
Let me see here. There's the chat.
The question is, can trace links be simply derived or calculated from the configuration records rather than having them explicitly stored? Is that kind of what you're suggesting?
Not necessarily, because trace links are between individual artifacts, and even if you know that, so an artifact is part of a configuration item that is part of the configuration, you wouldn't necessarily know that that artifact traced to that one. You can't just calculate that. A human still need to create that relationship initially. But what you can know, though, is when I branch this, or when I create a new version for a new system, have those trace links to come along, but adjust them automatically to now be between these two new versions. So I'm not creating a new version that points back to the old version of whatever that thing was pointing to. So I don't think you can you cannot compute the links between the individual artifacts based on just knowing if they are part of a configuration. That still need to be created, but these configurations can help you to adjust them after they have been created, when you, for example, revise stuff and create new versions.
Yes, I was thinking that by adding a configuration item to a configuration record
Mhm.
in a certain slot in that configuration record, like you put instance 12 in the A slot and you instance 76 in the B
Oh,
slot.
yeah.
So it's implied, the very fact that you put them in those slots, there's
All right.
an
Okay.
implied trace. And so now
Yeah.
it might be difficult to carry that all the way through, but
Yeah.
it's like
No,
the
I see what you're saying. That's exactly how you should think about it. Like, it's almost like you have your trace kind of web there, but I can unplug and plug in a new version of something, and please keep my trace links. That is exactly what we're kind of the behavior that we're looking for.
the trace
Yeah.
links end up being the semantics underneath the configuration record.
Right. Yeah, that I think is a good way to look at it that way.
So we're at time. I really appreciate it. We have one more question. Do you think you can get it quickly? It's from Jose. Is each requirements derived from some feature? So there is a link from requirements to some feature, whatever it's derived from, likely.
Yeah, when you create a featured centric set to use that kind of feature-based way of generating, then you need to kind of somehow label your let's say requirements with which feature they belong to. So yeah, that is correct. And some tools they will tell you, okay, here's how we do it, so introduce these things and it will work. Yeah. And it comes with usually a set of additional attributes to keep track of that. Yeah.
Well, thank you so much. I'm going to go ahead and stop the recording.